Hi everyone, can you hear me? Yes, okay, I can hear myself. So hello everyone, thank you for joining. There is a lot of interesting stuff going on, so thank you. Let me introduce myself quickly before we jump in. I'm Georgios, Ntanakas. I started my career with a PhD for the aerodynamic optimization of airplane engines, and then I quickly switched into the data space, both as a data engineer and then as a manager from companies from the size of like scale-ups up to Meta for a while. Currently, I'm the associate director for BI engineering in GWI, and one of the things I like to do is running. Starting with what existed before. First of all, in case you haven't heard GWI before, it's a company that is doing market research. And in BI, we're dealing with pretty much all data apart from this. So anything that has to do with sales and revenue data, marketing, expenses, the events from the GWI platform itself, people, data, employees, and hiring, and so on. So instead of presenting a system diagram of what we're going to call the legacy system, I'm just going to divide it into three pillars and briefly talk about it. First, just to clarify, everything like before and after was on the cloud. So starting with ingestion, what we had in place was one or two ingestion tools, but most of the integrations were done manually. So we had custom API integrations. For data transformation, we had views stored inside the database that we were running scripts on top of them to materialize them into tables. There was no real data modeling in those transformations. And in terms of execution, pretty much everything was based on cron jobs. So the team at that time found itself in the position of having delays into fulfilling even relatively, so to say, easy data requests. There were some reporting tasks that were cumbersome. There were concerns eventually about the data quality. And identifying where these data quality issues were was hard because of the no real dependency mapping of the data. So these were the symptoms. And when the team dived into like understanding what were the root causes for this, again, splitting them into three pillars. For ingestion, the development of new API integration was time consuming. Let's say a good estimate is about over a week per integration. Of course, doing that is error prone, especially for a BI team that is dealing with a lot of data sources of different formats. That's quite hard to do, and the debugging, of course, was tedious. In terms of transformation, there was, as we mentioned, no dimensional modeling. There was no version control because of the stored views that we mentioned. Quality testing was absent. Lineage was not there, so one had to go like manually over the different layers of transformations to understand like what's dependent on what. And there was no data dictionary. For the orchestration, no dependency mapping again, which jobs run after which one, and so on. That's hard to identify, and also the alerting was very limited. And the idea here was like, for every of these pillars, just tackle them like piece by piece. For every of these pillars, just try to find a solution that will solve the problems for this specific pillar. So for ingestion, what we looked for is investing, and I'm using the word investing on purpose because eventually what one wants to do is check how much time, development time, would he save by investing in a tool. So we wanted a plug and play experience that has a setup maybe in minutes or hours, but not days, to cover a wide range of connectors. We're mostly interested, of course, in the connectors that or the tools that we're using in GWI. Debugging to be easy, so full log coverage, maybe if there is support from the tool, even better. Of course, capturing automated schema changes, and for the tool to be scalable if the data ingestion needs increase. For data transformations, we wanted a software or a tool that allows us to set up quality checks easy after certain transformations. We wanted to have alerts, of course, if something goes wrong, and then maybe a monitoring interface to see that everything works as expected, check about the coverage of quality tests, and so on. For lineage, we wanted to have something that quickly, somebody can go quickly and understand like how the data is flowing through the different pipelines. We wanted, of course, to have a data dictionary to identify like data points, their definition easily. Dependency management as well. So we wanted the tool to be aware of what is running before, what after. So in case you go to a certain transformation and you run it and you want up-to-date data, we wanted the tool to understand like what's before it and run everything before. And we wanted it to be flexible as well. By flexible, I mean SQL-based. It's the language that a lot of the analysts speak, which are the consumers of our data. And for it to be modular as well. So we wanted to have all the best practices for coding, no repeatable code, and so on, plus utilities. Lastly, for orchestration, we looked to find something that is goes beyond quant jobs. So it supports event-based triggers, conditional or parameterized execution. We want to have, again, dependency management, ideally DAG-based workflows, and then a mapping for the dependencies between tasks within the same DAG or also holistically around all DAGs. We want it to be scalable, so support parallel processing, resource optimization, and the generation of DAGs dynamically if possible. And then, of course, alerting. So real-time alerting, so we can quickly act if something goes wrong and identify what's not working. And now I'm gonna just show you what we came up with first, and then talk a little bit about the migration process. So let's try to build this like block by block together. We're starting from a database. We're a data team, so that's a good idea. BigQuery was a selection here, and that was what was used in legacy, so relatively easy way to go. These were like some of the external data sources that we wanted to connect it into. Actually, those are the ones that we have already connected for the past like 6 to 8 months. Let's say, usually in a database, you have a raw layer where you put the data in, where it lands. And for that, we use Fivetran. It's one of the tools out there that supports this plug-and-play experience that I mentioned. There's a UI where you can quickly set up your connectors and bring the data into the database directly. There are other tools out there. Airbyte is an example. It's an open source one, or you can get the managed version as well. We're pretty happy with it so far and the time we're saving. And usually once you get the data in the raw layer, you need to clean them up, apply business logic on top of it, and for that, we chose dbt. It's one of the most popular data transformation tools at the moment. It comes with all the bells and whistles of transformation, like out-of-the-box lineage, data quality checks, of course, options for observability for the whole system, data dictionary, and the list goes on. Of course, once you have cleaned up data, transformed, you would like to show it to people. So we're using either exports to Google Sheets, Tableau for reporting, or even the Google Cloud Platform's native dashboarding solutions, Looker Studio. To add one more layer, of course, you need a tool to talk to Fivetran and dbt to tell them like when to run, and for that we're using Apache Airflow. And it's actually hosted by the dedicated service for Google Cloud Platform, which is the Cloud Composer. And to add one more last layer, the entire infrastructure is actually controlled by Terraform. Terraform is an infrastructure as code tool, and you set up as code pretty much everything from assigning permissions to specific users or groups, or even scaling up or down the resources for Cloud Composer, and everything that has to do with infra, really. Talking a little bit about environments, this is a simplified version of what I just showed you, so let's call this a production environment. For testing, what we are using is pretty much the same, but without using Fivetran to avoid being charged twice. So we're just cloning the data from production to the testing environment, and then development environment is similar, again without Fivetran, but also without Airflow. So for development, we're just using dbt. What would be very interesting to talk to you about, but I'm not going to because of time, is how the CI/CD is set up in this system. We're using GitHub actions for this. By the way, when this development of this whole thing started, there was one engineer and one DevOps in the team. Currently, there are like 2 engineers, data engineers, one DevOps plus myself. So one could say that it's a pretty agile system to maintain for a small team. In terms of migration now, initially we engaged with a consultancy to help us build an MVP of what I just showed you. And when that was done, it took a few months to get it up and running. We decided to put legacy into kind of maintenance mode where almost no new development is happening, and the two platforms coexist for about a year. We're actually very close of deprecating the legacy one. We started from core data into the migration process. We actually started from the things that we couldn't do with legacy initially. Apart from like moving data from one platform to the other when doing the migration, we also considered doing a business-wide dimensional model for the data that we are bringing into the new platform. And of course, we moved features from the old one to the new one gradually. While we develop new things into the new platform, we gradually migrate features from the old platform to the new one, trying to minimize disruption for the stakeholders. Here are some initial wins, as I mentioned from the past like 6 to 8 months. One of them was integration of Salesforce data. Actually, that project at the time coincided with a migration for the company from a manual way of tracking contracts to CPQ, a service of Salesforce, and that has already saved like 4 working days per month in terms of reporting. Another nice project that we run is Product Data Foundations. It's the first time that we tried to connect revenue data, Salesforce data, with the usage of DWI's platform. We have already delivered some early enablement deliveries for this one, and we're about to finalize it, saving over 1,600 hours per year. We have done projects for marketing demand generation, identifying keywords that are not very well performing in terms of the lead generation to cut down expenses for ads. We have built custom alerting on top of employee data modifications, reporting for hiring, and the legacy platform is soon to be deprecated. Last slide. In terms of learnings and challenges, the first one is involving DevOps early. We were lucky to have a dedicated DevOps engineer from the beginning, even working with a consultancy. And like there are numerous times in this 1-year path that I've said, yes, we did this properly. We do not need to spend more time into setting things up again. And Terraform has been a real ally on that path. Another lesson is that the initial supposedly generic design that we had in mind quickly became obsolete. So the way we are trying to overcome this is, instead of, sometimes we're trying to, like, we have the initial one and then we try to put patches on top of it to cover everything. We're now trying, whenever it's possible, to take a bit of a step back, take some time, and then refactor things so there's a more generic design to cover our needs. Another one is that even if you have a modern data platform, that will not fix upstream data inconsistencies. So along with the migration process, what we're trying to do is fix upstream business processes that lead to inconsistent data in. That is not always successful. We're trying our best here. Another lesson is that data modeling is hard. So once the tech stack was not an issue anymore, so we were like able to ingest data fast, transform data fast. Modeling it became the bottleneck. The way we're dealing with it at the moment is we decide to model basically what's core, like what's considered core data and what's interconnected with other tools. But the ones that seem siloed, we decide to have like a quick path to deliver results fast, and then maybe eventually if we need to connect it with the rest of the data sources, then take a step back again and try to redesign. But this is something we're struggling with still. And last but not least, you'll be surprised, but no matter how cool your platform is, if you can get like data mapping, lineage, dependencies of DAGs and everything in the end, it doesn't really matter if you do not deliver value fast. So what you need to show to the stakeholders, and we learned this as well, is new reports, new insights, or data that they can now trust. That was all. Thank you so much. Here's the slides. Any questions? Let me know. Do we have time for questions? I guess so, but we have no questions. Cool. Oh, yeah.
I would like to ask you about your experience with... can you hear me?
Yes.
Okay. So I would like to ask you about your experience with Terraform. How was it for this kind of project?
So Terraform is being used, we eventually followed company practices. And so we have a DevOps team which works with guilds, similar to the Spotify system, and pretty much all companies' infrastructure is maintained using Terraform. It works very well for us. So eventually we learned it as data engineers. We have a dedicated, as I said, DevOps who's working in other things as well. So we now are kind of Terraform champions. We are able to do basic things on our own. So we submit pull requests to the DevOps team, they approve and so on. We're very happy with it. And you can track things like giving access to, especially this kind of stuff, like for BI data that are sensitive, giving access to groups and have a monitoring of this is very valuable. Cool. At least I got one question, guys. So thank you so much, everyone.